Hello and welcome to another physics tutorial. So today we will be covering problem number 16 in the chapter 13, which talks about gravitation. So here in this problem, we have a mass here, which we can assume is a point mass, and a uniform rod with length L. And we want the magnitude of the gravitational force on the particle from the rod. So normally, our expression for gravitational force is F equals g/mm over r squared. But the issue here is that our distance with this rod is not constant. So what do? So what we want to do is we essentially split this rod up into many little tiny pieces, which is calculus, in case you haven't noticed. So let's take this little piece they have labeled here. So it exerts a force dF, which has magnitude of g times m1 for this mass times dm over a distance r squared. Now, however, we don't know anything about dm. So what we can say is that dm can be substituted with dr over L times the total mass m. So in other words, we have dF equals g m1m over Lr squared times dr. So now let's take an integral. So we do integral df, which is f, equals integral g m1m over Lr squared dr. So we have f equals g m1m over L integral 1 over r squared dr. Oh, this is from d to d plus L, by the way. So we have from d to d plus L here. So we use our power rule. So we rewrite this as r to the negative 2. So we take our integral and find that it is negative 1 over r from d to d plus L. All right. And then this expression means that we can get g m over L times negative 1 over d plus L. Normally it would be a minus, but because negative, it's now plus 1 over d. So our final expression is g m over L times 1 over d minus 1 over d plus L, which, if you plug in your values of d is 23 centimeters, L is 3 meters, and so on, you should get that the force from the rod onto the particle is 3 times 10 to the negative 10 newtons. Alright, thank you for watching. I hope you learned something about gravitational forces from uniform rods. Please like the video, subscribe to the channel, and I will see you later. Bye!